You'd start at -3 on the y-axis and just go up 1 over 2, right? So there's your linear function. So what is the domain and range of any linear function? The domain will always be what? And the range will always be what, right? All real numbers. Unless it's a horizontal or vertical line, because then it would only be like these values for x or these values for y. This is going forever left or right, and it's also going forever, it's climbing forever up and down. B, so this is a quadratic function. So first you need to know what is a quadratic function's key points. From the vertex at 0, 0, the key points are 1, 1, and 2, 4, and if you want to be fancy, 3, 9. This is just shifting the whole quadratic up 2 units. So when you have some number that's kind of outside the function, that's your up or down. Plus tells you to go up. So you go up 2 units, there's your vertex. The A value is just 1. So it's concave up and it's still just the parent graph. So over 1, up 1, and over 2 from the vertex, up 1, 2, 3, 4. So that would fit on the graph. So that is the parabola that's been shifted up 2. And then we have to say what the domain and range is for that function. So for any quadratic, the domain will always be all real numbers because it keeps spreading out left and right forever. But I don't have any y values down here, right? So the first y value is at 2, and all the y values are above that value. So the range is y has to be greater than or equal to 2. And domain and range go in alphabetical order. X and Y go in alphabetical order if you forget. So then this is an absolute value function. So that parent graph starts at 0, 0 and has a slope of up 1 over 1 and a slope of -1. So if there is a transformation inside a parenthesis or inside a function, inside a quadratic, that's your left or right. And I always tell students that inside parentheses, it's kind of like the strange world where everything's backwards. So a +4 actually shifts you to the left. So it's actually taking this function and shifting it left 4. So there's my new vertex. And if you forget if it's left or right, if I plug in the x value, -4, what is -4 plus 4? See how it's 0? So I'm just double checking that -4, 0 lies on this graph. So if you forget if it's right or left, try plugging in a number and seeing if it works. And then this is just flipping the graph upside down over the x-axis. So it just has a slope of 1 and -1, but it's going upside down. And if you changed the steepness, so let's say we did 2 times the absolute value function, that would change our slope up here steeper. So it would have a slope of 2. If it was only a slope of like 1/3, then it would be a lot like flatter of a graph because the slope is now 1/3 instead of 1. So the slope does change the kind of how stretched it is. So those are kind of the 3 main parent graphs that I want you to be able to move around. And on the quiz, I mean, a lot of it you don't even have to graph by hand. A lot of it is just asking you, hey, does this go up or down, left or right? Or hey, can you write the equation for this function? So you have to identify, is it absolute value or quadratic, and shifting it right, how would I write that function? And then in number 2, you had to write the function. So absolute value function that's been flipped over the x-axis, so it's upside down just like this one was. Shifted left 4. Oh man, is this that same function? I didn't do that on purpose. Absolute value, it's been flipped over the x-axis and shifted left 4. So it should be the exact same as that one up there. Did you get the same thing? That was a mistake. A linear function that's been just shifted up 8. I mean, I didn't say what the slope was. So if you wanted to write y equals x plus 8, I would accept that. But if you just said any slope, I mean, I would accept any slope. 2x plus 8, that's a linear function that's been shifted up 8. Just so your y-intercept is 8. And a quadratic function shifted right 2, so that's going to be -2 inside the parentheses, stretched by a factor of 4. X minus 2 squared. So I need the square to show that it's a quadratic. Stretched by a factor of 4. So that's going to be like really tall and narrow. That's what stretched means. You're getting taller. And we'll look at a stretch down here in 3b, 3x squared. So transformation rules. Do you have any other questions about transformation rules? On 3a, we can talk about transformation rules again, I guess. It's just something that I guess you've got to memorize. So do your best for today. Maybe make yourself some flashcards because you're going to need these transformation rules all year when we study exponential and log functions and whatever other type of function. That's probably it. Exponentials and logs. I can graph a quadratic in standard vertex or intercept. To me, this is just a transformation rule, almost like vertex form. It's a quadratic that's been shifted up 3, and it's flipped upside down, concave down. So you would just go up to 3 on the y-axis. And then I'm just going to flip that parent function upside down, over 1, down 1, and over 2, down 4. So there's my upside down parabola. So it's almost like the x-axis got shifted up 3, and then you're flipping it over that axis. Does that kind of make sense? Make sure that your parabolas look like parabolas. It shouldn't look like a V-shaped graph that are lines, because that's absolute value. It should be curved. B, this is standard form. Oops. This is your A, B, and C value, and you're going to do negative B over 2A to find the vertex. So negative 6 divided by 2 times 3 is 6. Did you get negative 1 as your x value of your vertex? Did some people get that? What do I do with the x value? So now that I know what x is, what do I do to find y? Plug it in. So I get positive 3 minus 6 minus 2. So 3 minus 8 would be negative 5. That's my vertex. So I go to negative 1, negative 5. I have to stretch my graph 3 times as tall. So normally, if the points were 0, 0, 1, 1, and 2, 4, you don't have to write this down, but it's the y values that are going to get stretched 3 times as tall. So 0, 0 is still 0, 0, but 1, 1, I'm going to go over 1 and up 3, because 1 times 3 is 3. So 3 times as tall, over 1 up 3. If I wanted to be 3 times as tall, this one would become a 12, because 4 times 3 is 12. I can't quite fit that, because that would be up here, right, just above that last grid mark. But you can kind of see how much steeper that parabola gets, and that it should be a curve, right, not a V-shaped graph. So it's not a slope of 3, because the next point's way up here at 12. And the last one was called intercept form. But if you don't like intercept form, you can multiply it out and just make it standard form. I'm just going to show you intercept form in case you like that. So this is a factor, so it has an intercept at negative 1. And this is another factor, so this would have an x-intercept at positive 1. And my a value is 1. So this is going to be a concave up parabola. I just have to locate my vertex. My vertex is halfway in between. So my vertex is at 0, something. So just like over here, I plugged in negative 1. I'm going to plug in 0. If I plug in 0, I get 1 times negative 1 is negative 1. So my vertex is at 0, negative 1. And this is just the parent function quadratic. So over 2, up 1, 2, 3, 4. So that's just kind of that parent function. It hasn't been stretched or flipped over. So I think graphing quadratics might be the more challenging part on this quiz. But I think if you could just remember negative b over 2a, maybe you can figure out the vertex. And then how are your factoring skills? Probably those of you that have already taken trig this year, you kind of are refreshed on your factoring skills, or if you just took algebra 2. But those of you that it's been a couple years, you've got to remember how to go through the process. You should always look for greatest common factor first. There's no greatest common factor in part A. Then you should always look for difference of squares. This is difference of squares. So the way you factor difference of squares is you take the square root of each of those parts. So you'd get 3x times 3x to get 9x squared and 5 times 5 to get 25. You make one a plus and you make one a minus. Difference of squares is always 1 plus 1 minus, because when you add your outer plus your inner, doesn't that add up to 0? Negative 15x, positive 15x adds up to 0. And then equals 0. So I didn't go over a lot of practice of the zero product property. How do I solve for x? It's not negative 5. So how do I solve for what x has to be? When there's a coefficient in front of the x, 3x plus 5 equals 0. You set up these linear equations. So how do I solve that for x? I'd have to subtract 5 to the other side, right? And then divide by 3. So one of my solutions is negative 5/3. This one I'd add 5 and divide by 3, so it's positive 5/3. Those are your x-intercepts. It's okay to not be an integer. We're going to get integers on this one, but so the zero product property, set them each equal to 0, solve for x. In B, I look for greatest common factor. Doesn't have one, or it's 1. Difference of squares. It's not a difference of squares, so it's trinomial. Do I need the diamond or the box? So I need the diamond because it's 1x squared. So I'm looking for the factors of 4 that add up to negative 4. Did anyone get this one factored on their own? Negative 2, negative 2. X minus 2 times x minus 2 only has an x-intercept at positive 2 because the graph bounces off the x-axis with that multiplicity we talked about yesterday. All right. And C, this one is the box method one. Doesn't have a greatest common factor, doesn't have difference of squares. It has an A value bigger than 1. So you've got to jump in and do the box method, unless you learned a different method at a different school. But I think most of you learned box. 4x squared and negative 15. We need to split this 4x up into these two boxes. So you use the diamond. 4 times negative 15 is negative 60. The denominator of that diamond is 4, or the bottom is 4. I heard Dylan find the answer. What was it? Positive 10 and negative 6, right? 10 and negative 6. That, it would be so nice if that was just your answer, but that gets filled into your box. 10x and negative 6x. And then you're looking for what goes out here to multiply to give you the box. So you don't want to use 4x times x, because if you put a 4x in either of these spaces, how are you going to multiply to get 6, or how are you going to multiply to get 10? So you want to use whatever is going to work for the next box over. 2 times 2 is going to give me that 4x squared. So now 2x times what will give me 10x? So I'm putting a 5 here. And then 2x times what will give me negative 6x? I'm putting on negative 3 there. And then 5 times negative 3 is negative 15. So 2x plus 5 and 2x minus 3. If you didn't get a chance to get this one done, why don't you take 30 seconds and try solving for your x-intercepts now that you're at that step, just to make sure you understand how to do the zero product property and solve for x. So let's give you 30 seconds to practice solving that. So you'd get negative 5 over 2 or positive 3 over 2. So negative 2.5 or 1.5 are your x-intercepts. And does anyone want to offer up? Oh. We're not talking about it. Okay. So can you name a polynomial? What is this polynomial called? What name did you give it? Is it linear? Is it a trinomial? Yeah, what name would you give it? No, it's not a trinomial. It is not linear. Ah, you're scaring me. If I write this in standard form x cubed minus 2x, does that help you out? Now what type of, it's cubic, and it's a binomial, meaning it has two terms in it. I didn't have you name it on the quiz, but next week on Friday, it will be. But you need to be able to state the degree and the leading coefficient on the quiz. So what's the degree of this function? And what's the leading coefficient? Yep. Right. So, I put the degree, leading coefficient, in standard form on the quiz, but yeah, I need you to be fluent in that vocabulary as we move through the school year, but I didn't put it on today's quiz, but it will be on next Friday's. Okay, what would you name B? B is already in standard form. What would you call that function? Linear, and it's also a binomial. I guess I should have put more than one. I should have put like a monomial or something. And what's its degree? 1. And what's its leading coefficient? It's -5. Because the leading coefficient tells you if it's going to be concave up or down at the end behavior. All right. So next, I wanted to